How can you identify anagrams easily? You are given some strings and you want to group all of the anagrams together, right? The output should be a list that has all of these anagrams grouped together. I will show you two different methods to solve this problem and get it accepted. If you want a quick solution and you just want to see the code, you can refer to the link in the description below to my GitHub profile. However, if you want to see how I came up with the solution, welcome back to Study Algorithms, a place where I simplify programming for you with animations, visuals, and some really easy to understand examples. Today, we would be solving a problem on LeetCode. The problem we would be solving today is group anagrams. First, I will describe you the problem statement and show you some sample test cases. Then, we will try to solve this problem by categorizing using sorting. I will also show you a second solution where you can categorize using the frequency of characters. Going forward, I will do a dry run of the code so that you can see how all of this actually works. So, without further ado, let's get started. The problem here is pretty straightforward. You are given an array that has some strings and you want to group all of the anagrams together. All you need to know is what are anagrams. So, two strings are basically said to be anagrams if they are made up of the same number of characters. If you look at the word listen and the word silent, you can see that they have the same characters and the frequency of each character is also same. So silent is formed from S, I, L, E, N and T, and in the word listen also you can find the same characters, right? And hence silent and listen are said to be anagrams of each other. Now, to understand the problem even better, we can go over some sample test cases. Let us look at our first test case. You have an array of some strings, and the first string is eat. This string is formed from the letters E, A, and T. If you look closely in the array, what other strings can you find that have the same characters? You can see that T also has the same characters E, A, and T, and 8 also has the same characters A, T, and E, right? So this looks like one group. If you look more, you can see that you have a string TAN and you can find one more string NAT. This also has the same characters as TAN, right? So this would be another group. If you look at the remaining string, that is BAT, that is a group in itself. So in your resultant output, you can find three groups. You would have one group that only has BAT, you would have a second group that has NAT and TAN, and in the third group, you would have 8, EAT, and T. So what you did is you grouped all of these anagrams together, right? Similarly, in our test case number 2, if you see I have the word eat and T. They have the same characters, right? And hence they form a group. So even in my resultant output, I have this as a group. It is not necessary that you can only have three characters. If you see, I have more anagrams in here. The word cars and scar also have the same characters, and hence they also form a group. A single letter is a group in itself, right? And hence you have the third group of a single letter A. And hence, once again, you were able to group all of your anagrams. In a test case number 3, that is kind of an edge case. Your input is empty, and hence your output will also be empty. That is because you weren't able to find any groups, right? That seems very obvious also. Now, a brute force solution to this problem is very obvious. You can try to take up every string and compare if it is an anagram of the other, and then form all of your groups. But this will take up a time complexity of order of n square. However, we want to improve it, right? So let us see how we can go about doing it. To come up with a solution to this problem, we need to take advantage of the fact that we need to find anagrams. And we want to find what properties of anagrams can we use to our advantage. So if I take up my original example of the words silent and listen, these both are anagrams, remember? That means these two strings have the same characters and the same frequency. So if I sort both of them, then they should look alike, right? So if I sort silent, it becomes something like this. And if I sort the word listen, then it becomes something like this. So you can see that after sorting, voila, I am able to see the same string, right? So can we use this property to our advantage? Let us see what we can do. You know that you have to group all of these anagrams, right? So I am taking a map where I can group all of these strings. So for the key part or the left column of my hash map, I would be taking a sorted string, and for my values, I would be having these groups. How do we populate this hash map? Let me start off with the first string, that is eat. So I sort this word. As soon as I sort eat, I will get the word A, E, and T. This is sorted, right? So what I do is I check my map. If I cannot find this word in my key, I add this as a key and I add the corresponding string for which I got this result. So you see, I added one string to my hash map. Going forward, I take up my next string, that is T. I will again try to sort it. As soon as I sort it, it becomes A, E, and T. Now, you will try to look up this sorted string in your map. This time, you can find it over here, right? So, what you do is, you add up this string in your values. So, T would be added over here, correct? Going forward, I get my third string, that is tan. Now, if I sort this, it becomes A, N, T, right? Again, you will try to look up this string in your hash map. You can't find it. So what I simply do is I add up A, N, T over here, and I will add the corresponding string to my group. Notice that in the keys, I am just putting the sorted string because when you sort these anagrams, they should turn out to be the same, right? And you will use this property to group all of them. Once again, when you move ahead, you see the word 8. If I will sort it again, it will become A, E, and T. I can find this again in my hash map, so I simply add A, T over here. Moving forward, I see the word NAT. Sorting it changes to A, N, T. I can find it in my hash map, so I add this word over here. And now for the last word, I see BAT. Sorting it changes into A, B, T. I cannot find it in my hash map, so I add it over here and I add the corresponding word in here. And hence, you see, I was able to find out all of my groups. And you need to return this list of strings as your answer. Note that the time complexity of this solution would be order of n log k, where k is the length of the maximum string and n is the number of strings. That is because you're sorting these strings, right? And if you try to implement this solution, you will get an accepted answer. However, we can still improve this. Let us see how. You see how we were able to take advantage of the fact that you need to find anagrams. So we are leveraging properties of anagrams. You know that anagrams would have the same characters, right? But also, if two strings are anagrams, then the frequency of those characters is also same. And we can take advantage of this fact. Suppose we have these two strings, me and keen. These two are anagrams, right? You can see that they're formed from the same characters, right? But if you also notice that in these two strings, you have two E's, one K, and one N. And can we take advantage of this property to categorize all of our anagrams? Let us see what we can do. Once again, I am creating a hash map where I would be grouping all of these strings together. But how to fill up this map? Let us take up our first string, that is AAB. So if you look closely, this string has two A's and one B. So I can say A to B1, and this can be a frequency string because it is telling me that I have two A's and one B in the string. So just like our previous method, what I can do is I can put up this string in my keys A to B1 and add the string that I found, right? Going forward, I have my second string ABA. In this string also, you can see that you have two A's and one B. So I again got my same frequency string. I found this in my map, so I add this string also to my values. So you see, now we are forming groups. Going over to my third string, somehow I have the same frequencies again. I have two A's and one B, and I will use this frequency string to search my map. I can find this in my keys. So I add this value also to my map. Going ahead to our last value. If I create a frequency string out of this, it turns out to be A1, B2, and C3. Now, I can't find this string in my frequency map, right? So I will add this A1, B2, and the corresponding string in my values, right? So you see, this is how once again we are forming groups. Let us say I had two more strings in my original input array. Now, what happens if I try to create frequency strings of my new elements? So this turns out to be A1, B2, and this turns out to be A1, B2, C3, right? If you look at our hash map again, you can't find A1, B2. So you would add A1, B2 in here and the corresponding string, and you can find A1, B2, C3 in your frequency map, and hence you will write down the corresponding string for your values. So you see, once again, I was able to group all of these anagrams together, and this will be your answer. Notice that you can find this frequency string in a time complexity of order of k, where k is the length of the largest string, and if you have n strings, then you need an additional time complexity of order of n. And hence, the total time complexity of this solution would be order of n multiplied by k. You can argue that this solution would be a little faster because you're not sorting your strings over here. If this solution is now clear to you, let us do a dry run of the code and see how this works. To understand the dry run, let me take up an example array where we would be grouping all of these anagrams. On the left, you have the actual code to group all of these anagrams using the frequency method. So you have your input parameters strings. That is a array of strings. Next, you check your edge cases if you're passing in an empty array or you don't have any strings. Going forward, we create a frequency strings hash map. So in this map, we would be storing the frequency string and all of the values as a key value pair, correct? Going forward, I start a for loop that will iterate over each of the element in your array. So you start off with your first string AAB. Next, you pass in this string as a parameter to a function to generate the frequency string. I will tell you in a bit how this frequency string is generated. But you already know from our methods that for the string AAB, the frequency string would be generated as A2B1. Going forward, we check if this frequency string is present in the map. Since it is not present, what I do is I create a new list and I add my original string to this list.
Today we're going to learn about hash tables. Similar to stacks and queues, hash tables represent a dynamic set of data. Hash tables support insert, delete, and search operations. Where hash tables really shine is search. As they have an average search time of big O of 1, although this degrades to big O of n in the worst case. I'll start by noting that the term hash table is sometimes used interchangeably with dictionary. Dictionaries represent a generic way to map keys to values. Hash tables are a specific way to implement a dictionary using a hashing function. You've probably seen or worked with dictionaries or hash tables if you've done basic programming. Here's Python code showing dictionary usage. Let's talk about our key value mapping implementation. To do this, we'll start by exploring a similar concept to hash tables called direct access tables. With direct access tables, we have a universe of keys shown on the left. Some of the keys are in use and they point to data. With direct access tables, insert, delete, and search are all constant time operations. In other words, a direct access table is an array. And if you need to represent every key in the universe, we say U is unbounded and impractical to store in memory. Enter hash tables. With hash tables, the space requirement is big O of k, where k is the number of keys. To achieve this, we introduce a hash function that maps keys to a location in the table that holds data. Because our universe of keys is no longer unbounded, it's possible to concept to hash tables called direct access tables. With direct access access tables, we have a universe of keys shown on the left. Some of the keys are in use and they point to data. With direct access tables, insert, delete, and search are all constant time operations. In other words, a direct access table is an array. And if you need to represent every key in the universe, we say U is unbounded and impractical to store in memory. Enter hash tables. With hash tables, the space requirement is
Introduction to hash tables.
in the last
यार ये माइक तो ऑफ था यार. God, man. How can I do this?
Hey everyone, welcome back. Hey everyone, welcome back to the channel. I hope you guys are doing not be able to solve a lot of problems in data structures and algorithms. So please do not miss this lecture because I'm going to teach you hashing and I'll be using pseudocode. So language will not matter. Everything that I'll be teaching will be in terms of pseudocode because for loops are similar in C++, similar in Java and Python. So once you understand the pseudocode, once you understand the concept, you can actually code it in any of the languages that you're following this particular course in. So in order to understand hashing, let's take an initial problem. Imagine you're given this particular array and now suddenly I come up and say, hey, can you tell me how many times does 1 appear in the array? And you can say that, hey, 1 appears twice in the array, right? Because 1 is appearing once here and 1 is appearing once here. So 1 appears twice in the array. And again come up and say, hey, can you please tell me how many times does 3 appear in the array? Now you'll be saying 3 appears once. Now imagine I again come up and say, hey, can you tell me how many times 4 appears in the array? You'll be saying it doesn't appear in the array. Now imagine I again come up and say, hey, can you tell me how many times does 2 appear in the array? You'll be like 2 appears twice. Imagine I again come up and say, hey, how many times does 10 appear in the array? You'll be like, hey, listen, 10 doesn't appear in the array. 10 is appearing 0 times. So given an array and you ask a lot of times, very, very important point, very, very important point. You ask a lot of times. First, you might be asked for any given given number, then any other number, then again the same number, you could be asked for any given number of times for any number, and they might ask you how many times it appears, and you have to tell. Now, what is the first approach that comes to your mind when you think about it? Because you know for loops, right? The first approach that comes up is, hey, if someone says the number is 1. The first approach that comes up to my mind is I will iterate through the entire array. What I'll do is I'll take this 1 and I'll compare it with the first guy, 1, and I say yes. And I'll take a counter variable which is 0. I'll say this is equal to this, so I update it to 1. Next, I'll go to 2 and I'll say, is this equal to 1? I'll say no. Next, I'll go to 1 and I'll say, this is equal to this. So the counter which was 1 previously will be updated to 2. Next, I'll go to this and I'll say, is this equal to this? No. Next, I'll go to this and I'll say, is this equal to this? And no. So the counter stays at 2. So if I have to write the brute force method in order to find how many times it appears, can I say it will be a function which takes a number. I'm writing a plain pseudocode. It will be a function which takes a number and probably an integer function because it has to return how many times it appears. And you can be like for loop int I, or rather you also need the array in the function. So go ahead and take the array as well. Int function and probably array. Again, I'm writing the pseudo code, guys. I'm just writing the pseudo code. Please focus on the logic. So can I say, probably I'll take a counter equal to 0 and I'll say for I will loop from 0 and I'll loop till the last of the array. You already know this. How do you loop in the array, right? And you will say, hey, if array of I is equal to number, can I say counter equal to counter plus 1 and I can end this for loop and I'll say return counter and this will be my code. Can I say this? Yes, I can say this. Why does this work? Because it's very simple. If you're given a number 1, that number 1 is given over here and the array is given over here and you iterate through the entire array. What is 0th index? This is this. What is after this first index? This is this. And what are you doing? You're saying array of 0 equal to 1. Then you are increasing the counter. So eventually you will iterate through the entire array and the counter value will be updated at the end of the for loop. Once it is updated, you return the counter, correct? So in order to find how many times 1 appears in the array, what you can say is, hey, function, take 1 and take this particular array and tell me how many times it appears and it will return you 2. In order to find out how many times 3 appears, you'll say, hey, function, take 3 and take this particular array and say how many times does 3 appear, and it does a linear iteration. It goes to every element and checks if it is equal and it counts it, and at the end of the day it returns the count. Simple. So if I have to ask you, what is the time complexity? Can I say I'm running a loop for bgo of n times and there are certain number of operations that we are doing, but we do not calculate that in time complexity. So can I say I'm running the loop for n times? Thereby the time that I'm taking in order to compute how many times a number appears is bgo of n. So for this, I will take bgo of n. For this, I will take another bgo of n. For this, I'll take another bgo of n. For this, I'll take another bgo of n. For this, I'll take another bgo of n. So can I say for 5 times, if I have to do 5 times, like these are 5 numbers, for 5 numbers, if I have to find how many times each of these numbers appear, can I say the time complexity is 5 into bgo of n? I can say. And imagine if I give you a lot of such numbers, like a lot of such numbers. If I give you a lot of such numbers, and imagine there are q numbers. I give you q numbers, and for every for every number, you have to tell me how many times it appears. Can I say the time complexity will be q into n? Can I say the time complexity will be q into n? Because for every time you are taking a for loop and computing it, so thereby the time complexity will be q because there are q numbers, and for every time you are computing n, so the time complexity boils down to q into n. And this is something which might not be good. If imagine q is very large, just imagine I'm giving you q to be 10 to the power 5. I'm giving you 10 to the power 5 numbers. And imagine I give you an array size. I give you a huge array of 10 to the power 5 size. Then what will happen? Then it will be bgo of 10 to the power 5 because 10 to the power 5 numbers will be there. And the array size is 10 to the power 5 because it's a huge array. So the number of operations will be 10 to the power 10. And the number of operations is 10 to the power 10. How many time, how much time will it take? If you remember, I told you 10 to the power 8 roughly takes around 1 second. Most of the problems you'll find on DS Algo will be taking 1 second or 2 seconds. So if I'm taking 10 to the power 10 operations, how much time will it take? It will take 10 to the power 10 seconds will take approximately 100 seconds. How do I get that? Very simple. If 10 to the power 8 takes 1 second, then one operation will take 1 second by 10 to the power 8. Then 10 to the power 10 operation will take 1 by 10 to the power 8 into 10 to the power 10, which is nothing but 10 to the power square, which is nothing but 100 seconds. So 10 to the power 10 will take 100 seconds, which is a lot of time. You cannot wait for 1.5 minutes for a program to execute. This is where something like hashing comes in. It's a technique which will help you to do it in a much faster way. So if I have to define hashing in extremely naive terms, what is it? It is something like pre-storing and fetching. This is what hashing is. Pre-store something and fetch when required. Let's understand this in depth. Now this is an array. Okay. Now imagine the problem statement states the array will at max have numbers till 12 or 15. Let's say 12. At max it will have 12. What does it mean? Over here you're saying 1, 2, 1, 3. So at max over here it is 3. But imagine a problem statement where I state I'll give you an array and the array at max will have 12. Over here it is having 3 at max, but the array can have at max of 12. So what hashing says is, okay, I know I can have numbers from 0, 1, 2, 3 till 12. So what I will do is, I will create another array, okay? Remember this, I'll create another array and I'll call this as hash array. And in this hash array, what I'll do is, I'll say 0, 1, 2. So what I'll do is I'll create an array of size 13. And I know the indexing starts from 0 and the indexing will go on till 12. And I'll assign everything as 0 initially. And this is something which I'll call as hash array. This is something which I'll call as hash array, or you can call it as a frequency array as well. Now what I will do is, I will do some pre-calculation. Remember this. I will do some pre-calculation. Now what is this pre-calculation? It's very simple. I go to the first number, which is 1, and I say, okay, you are 1. So I will go to the first index and I'll say, hey, can you just remember that I have 1, 1? So he will say, okay, I'll remember you have 1, 1. Next, I'll go to this 2. So it will come to this 2 and say, hey, can you remember I have 1, 2? He'll say, okay. Next, I'll go to this 1 and it will say, go to 1 and say that he has 1 more 1. So he goes to 1 and says, you have 1 more 1. So he says, okay, I know I have 2 1s. He'll go to 3 and say, can you go and remember you have 1, 3? He will do that. He goes to 2 again. He says, go and remember you have 1, 2. So 2 increases to 2. So apparently, the moment you have traversed for all the elements in the array, the hash array, if you properly observe, in one index, because 1 is the number representation, in 1 it states, I'm appearing appearing twice. In 2 it states, I'm appearing twice. In 3 it states, I'm appearing once. And all the others are marked as 0 because they do not appear. So now, this is the pre-store that you have done. This is the pre-store. This is the pre-fetching that you have done. Now what will happen? Now you come over here and you say, hey, listen, how many times 1 appears. Now you do not loop and find out how many times 1 appears. What you say is, hey, how many times 1 appear? I have done a prefetching. I'll go to 1 and I'll say it appears twice. I get twice. For this one, I go and say how many times it appears, and I'll get this value at hash of 1. Instead of iterating in the entire array, I say hash of 1 and it tells me 2. For this 3, I'll say hash of 3 and it will give me 1. For this 4, I'll say hash of 4 and it'll tell me 0. For this 2, I'll do hash of 2, it'll give me 2. For this 10, I'll do hash of 10, it'll give me 0. For this 12, I'll do hash of 12, it will give me 0. So can I say I just did a single, can I say I just did a single pre-computation and that apparently solved all of my queries in one go? So if I have to code this up, can I say I'll first be given the size of the array. Imagine this is 5 size array and 1, 3, 2, 1 and 3. So given this array, then probably I'll give you the number of numbers for whom I require, how many times they appear. I tell you I need for 5 numbers. And the number is, first I'll say how many times 1 appears. Next I'll say how many times, let's say 4 appears. Next time how many times 2 appears. Next time how many times 3 appears. Next how many times 12 appears. So 5 numbers for which I have to find how many times they appear. So this is the size of the array. This is the array. How many numbers, like how many queries are you giving? And these are the queries. 1, 4, 2, 3, 12. Tell me how many times 1 appears. Tell me how many times 4 appears. Tell me how many times 2 appears. Tell me how many times 3 appears. Tell me how many times 12 appears. So I need to take all of these inputs. So it's a very simple way. First n and then scene of n. Then you declare the array of size n. And then you say for int I equal to 0, I lesser than n, I plus plus. Then you go across and say scene of array of I. Perfect. You've done this. What's the next step? You have to take the query. So first I'm taking up all the inputs. Okay. Scene of q. So you can run a while loop like q minus minus. And then you can say take me the number and scene of number. So this is what is the input. First the array, then the queries, and for every query the number. Now you need to tell me how many times the number appears. So this is where you do some pre-compute, and this is the fetch method. This is where you fetch. So can I say for pre-computation, I need hash. I need a hash. And over here, for simplicity purpose, let's take 13 because I know at max the size can be till 12. Whatever the problem states, if the problem states the maximum size can be till 10 to the power 5, then you will go across and say 10 to the power 5. If the problem states 10 to the power 6, you go across and declare it. Over here, I've kept it simple. I've said that maximum size will be 12. So I require a size 13 because in order to have the 12th index, I need a size of 13 because the last array index is 12. All of us know that. Now, the pre-computation was very simple. I will go like this to the array. This is the iteration of the array. Now, I know for array element, I have to go to that index and do a +1. So I say, hey, go to that index, which is array of I, because that is the index where I have to go. And I have to tell him, can you increase your value by 1? And he increases because previously it was 0. Now he will, for every number it goes to that index and says plus equal to. Once this is done, now I have my hash array ready. So if I go back to the iPad, can I say I have this particular hash array ready after the pre-computation? Because 1 means hash of 1 plus equal to 1. So it goes to this and does a 1. Tell you that the maximum array element can be till 10 to the power 9. Like it can have numbers till 10 to the power 9 or maybe 10 to the power 12 or maybe 10 to the power 15. What if they have larger numbers? Can we declare an array of size 10 to the power 9 plus 1? Because apparently that is what we are seeing. If there was an array of size at max till 12, we declared a size 13. So if the array has max element till 10 to the power 9, can we declare an array of size 10 to the power 9 plus 1? The answer to that is no, you cannot. The maximum size array that you can declare is 10 to the power 6 if it is of integer. Inside, very important, inside main, what does it mean? If I go back to the code, this is where you declare. If you're declaring it inside main, it can only go up to 10 to the power 6, like somewhere near about. You cannot declare something like 10 to the power 7. This will throw you segmentation fault. It will not be able to allocate that much memory. But, if you go across and declare it somewhere globally, which means over here, if I go across and declare somewhere globally, I can actually do it till 1e7, which is 10 to the power 7. So if you declare globally the array can go till 10 to the power 7 as well if it is declared globally. Like 10 to the power 7 plus 1 might also work. Near about 10 to the power 7, it will go. But if it is declared globally, very, very important. This is something which I'm talking for integers because we are dealing with hashing. For Boolean, yes, for Boolean, this value will be if you're declaring a Boolean array, inside int main you can go till 10 to the power 7. Globally, you can go till 10 to the power 8. You can run them and see. If you declare anything like 10 to the power 8 inside, yes, inside your int main, it is going to throw you a segmentation fault. So let's go into the code editor. If you're declaring a Boolean array, inside int main, you can go till 10 to the power 7. Globally, you can go till 10 to the power 8. You can run them and see. If you declare anything like 10 to the power 8 inside, yes, inside your int main, it is going to throw you a segmentation fault. So let's go to the code editor and imagine instead of 13, I said 10 to the power 7. Okay. And now let's try to run this and see if it is taking 10 to the power 7. So if you look at the terminal, it actually says there is a problem because the memory size is something which it cannot allocate. But the moment I reduce 1 0 and I try to rerun, you will see that this is actually running fine. Let's run this. You see it is running fine. And if I add one more 0 and I go across and declare this globally, you'll actually see this is like, you don't need to give 0 because if you declare globally, everything is initialized as 0 instead of garbage values. So if you go over there, I declared it. Okay, what is the problem it's giving? Oh, shoot. Let's run this. Hash is ambiguous because okay, let's do double hash because the name is something which is already taken. Let's now run it. And you see it is working fine. If I declared it globally as 10 to the power 7, it did run fine. So this is something which I wanted to tell you. This is something which I wanted to tell you. If you are using array in order to do hashing, you can only go up to 10 to the power 6 inside a main or 10 to the power 7 globally, not beyond that. For something like 10 to the power 9, what will we be using? That is something which we'll be discussing in the later half of the video. So make sure you watch the video till the end. So till now, what have we learned? We kind of learned about number hashing. If there is a problem which requires number hashing, we can use arrays to hash them, right? What's the next thing that we will be learning? That is something as character hashing. Can we do character hashing using arrays? Yes, we can. And that is something which we will be learning. Imagine I give you a string like A, B, C, D, A, B, E, F, C. And I give you certain queries. And I ask you how many times does A appear? Can I say once, twice is what A appears? How many times does C appear? If I ask you how many times C appears, it will be 1. And again twice. How many times Z appears? It will be 0. If you look at over here, that doesn't appear. And similarly, I can give you a lot of other things like Q queries. I can ask you Q times A, B, C. I can give you any character, and it is your task to tell me how many times does that character appear in this particular string. Again, what is the standard procedure? The standard procedure is very simple. You pick up A and you iterate in the string and you say A equal to A. Yes, count A equal to 1. A equal to A here, count A equal to 2. So you just basically iterate through the string, and in a similar way, you compare the character with each of the characters and you count it. So if I have to write the pseudocode, this is how the pseudocode will look like. You take the character C and you probably take the string C. And what you do is you keep a counter 0. And now you go through the string I equal to 0. Imagine the size of the string is n. You go till that and you say if s of I is equal to character C, then I will do a counter plus plus. And at the end of the day, I can return that counter. So this is what the simple pseudo code will be. For every character, you go ahead. Again, if you do the similar thing for Q queries, how much time will you end up taking? For every query, you are taking n. So for Q queries, you'll be taking big O of Q into n time, similar to the previous problem. So the question
大丈夫だ。